Hello, this is Dr. Mears. Today we are going to be going over measures of dispersion, also known as spread. This video is going to go relatively quickly. I wrote out most of the things, so please do not hesitate to pause so that you can write down all of the good stuff. So first, let's look at this document that I typed up for you. Let's just read through it. First, measures of dispersion measures how spread out the data set is. So if we go from 1 to 100, or do we go from 1 to 50, or do we go from 2 to 10? So that's what we're going to be looking at, different types of spread. There are 3 types of measures of dispersion. The first one is called range. Range shows the full spread of the data. The range can be calculated by taking the maximum number and subtracting the minimum. You have to subtract the 2 numbers to actually find the range. The range is 1 number. The second type is the interquartile range. This measures the range of the middle 50% of the data. In order to find your interquartile range, also known as IQR, we subtract quartile 3 minus quartile 1. Subtract the 2 numbers. The IQR uses median as the measure. So when you are talking about quartiles, you are talking about probably making a box plot, and when you make that box plot, your median is that center. So if you want to talk about IQR, you're going to have to also talk about median as well. The last one, number 3, is the standard deviation. Standard deviation measures the typical distance of the values from the mean. Standard deviation uses mean as measure of center. Use your GDC, your graphical display calculator, to calculate the standard deviation using our 1 variable stats, and that's on that calculator sheet that we've been doing. The IB notation for standard deviation is S sub n. However, when you use your graphical display calculator, they want you to use sigma x. This is a little bit different, so be careful. It's sigma x that they want you to use. Now, before we go on to our examples, I just want to go back to interquartile range and standard deviation, because these are 2 that use different measures of center. This uses the median, in which I did mention that we use a box plot, which you'll recognize as this. We'll use a box plot, and the median will be here, and you have quartile 1 and quartile 3. Now, you usually go to draw a box plot to represent your data if you notice that your data is skewed. So if you were to make a histogram and you notice that it was skewed either to the right skew, or if it was skewed either to the left skew, this means that your mean and your median are not equal. One is greater than the other. So when we use the interquartile range, our data is going to be skewed. Now, when we use standard deviation, which uses mean as measure of center, that's when our data is going to be symmetric. In symmetric data, our mean and median are equal. So this is symmetric. And so if we were to graph a little histogram right here, the mean would be equal to the median. Here, it's not. Here, the mean is either greater than the median, or the mean is either less than the median. And this was another video you learned about right skew, left skew, and when it was greater than or when it wasn't. So if you want to go back because you don't remember which skew matches up with greater than or less than, please go back and review that. I'm just refreshing your memory. This video is not about how to determine skew, it's about what spread means. So let's go on to our examples. If you turn the page, the first example that you are going to find is example number 1. It's about the number of little piglets that went to the market over the course of 10 days. So day 1, 10 went to the market, day 2, 12, day 3, day 4, so on and so forth. So there are 10 days here. We need to find the mean, standard deviation, range, median, interquartile range, so on and so forth. So when you use your graphical display calculator, this is a single set of data. So you take out your graphical display calculator and you are going to go into Stat Edit, and you're just going to put the data into L1. So you're really just going to enter, and again, you should really be comfortable with this by now, the numbers here. And then let's make sure we do have 10. Let's make sure that they're correct. 10, 12, 12, 13. Okay. When you do this, we're going to be doing a stat, and we're going to be doing it just on that single set. So here we have the mean equaling 12.2. So let's write down our numbers that we need. You know how to pick those out. So x bar is going to be 12.2. Our standard deviation, please remember to use this symbol, 2.18. We do 3 significant figures. Our range is going to be our max of 16 minus our min of 9, so our range is going to be 7. Our median is going to be 12, and our interquartile range, which is going to be our Q3, 14 minus our Q1, 10, so that's going to be 4. So now that we wrote down all of our numbers, let's go back to interpret what they mean. So here, the mean, this is the average. So the average number of pigs that went to the market was 12.2 piglets. A lot of people want to round. What I suggest for rounding, if you would like to round this to, there was 12.2, so about 13 you can say, but I really do want the decimal. So please put the decimal down. I know you can't have 0.2 of a piglet, so you can rewrite it in the sentence rounding, but please put that decimal down. It's very important. Okay, so the standard deviation here, these are piglets, and I always go back to put in my labels so we know what we're talking about. So what this means is this is the typical distance of the values from the mean. So the typical distance of the values from the mean is, let's see, 2.18 piglets. What does this really mean, though? This really means if we went 1 standard deviation below the mean, we would get to, and this is how we're going to calculate it, 12.2 minus 2.18. So we're actually going to subtract 1 standard deviation. So 12.2 minus 2.18, we get to 10.2 piglets. Okay, well, 1 standard deviation above, you would do the same, but you would add. So we would do 12.2 plus 2.18, and we get to 14.38 piglets. So 1 standard deviation ranges, and I'm going to put STDV, ranges from 10.2 piglets to 14.38 piglets. And we can do 2 standard deviations, 3 standard deviations. However, we're not going to get into, this is talking about having a normal distribution, and we're not going to be getting into normal distribution as of yet. But I do want you to understand that we have this measure of spread about the mean, and it's called standard deviation, and that's what I would like you to begin to understand right now, and then we'll delve into that big topic later. Okay, so now the range, let's just pull it back a little bit. The range, that's just the overall, looking at the max and the min. So the lowest number was 9 piglets, and the highest number was 16. So the entire range of the data spreads from 9 to 16 piglets. So the range is 7 piglets. Okay. Next, the median. The median is the middle number of piglets. So we have the middle number of piglets is 12, which means that 50% of the piglets, 50% were 12 piglets went. That 50% of the time, those 12 piglets went for those number of days. So if we're looking at 10 days, 50% of those 10 days, up to 12 pigs went, or 12 or more pigs went. So remember, that brings in your 50%. Between 9 to 12 piglets went to the market. And you can do the other way too. You can do 12 to 16 pigs if you want to go to the higher end. So above 50%, below, but that lucky number is 12 piglets. In our interquartile range measures the middle 50% of the data. So 50%, the middle 50% of the days, 4 piglets, span 4 piglets, sorry. Span so between 14 and 10. So if we were going to do a box plot, this would be 10 and this would be 14. And we would say this is the middle 50% of the days. So it spanned right here 4 piglets. Okay, so with all of this being said, let's look at another example. So this was really going over the interpretations using a single set of data. Let's just look at example 2 right now. This is example 2. Find and interpret the mean, standard deviation, range, median, IQR for both boys and girls. Use your GDC when possible. We have 50 students that were asked the total number of points they received on their IB diploma. The results are shown in the table. Here we have our score. So this is going to be our L1. Now you can do this in 3 lists if you were like. So you can make this L1 and you can make the boys, because this is the boys' frequency of points. You can make this L2 and you can make this L3 because this is the girls' frequency. So when you're doing this on the graphing calculator and you do stat edit, what you can do is you can put in, and if you look, I've already put in the other 2. Okay, so this is that these are the scores. This is the boys' frequency. That's the girls' frequency. So if you wanted to do a stat and you wanted to run just the score with the boys, you can get the score and the boys' data. If you wanted to just do that for the girls, instead of pushing L2, you'd push second 3. So now you can get the score with the girls. So it's really nice because you can do this both. However, with that being said, you could just do the old-fashioned way where you erase it. This is going to be the data on, this is the boys and this is the girls. So why don't you try that on the calculator right now, pause the video and come back, because I'm going to show you the write-up. Okay, welcome back. So now we had to write up what it would look like. So if you had to do this for your IA, this is the write-up that you would be doing for your IA. So take a minute, read it over, pause the video, call me over. If you don't understand it, if you want me to go through it with you sentence by sentence, absolutely fine. So please call me over and go through it. Read it first though. If you'd like a copy, I have some copies for you that you can get. So let me know when you're at this point. Good luck. Hope this helped. Bye.